Time-lapse photography is a fascinating hobby. Scenes that appear stationary and flat come alive simply when the motion is revealed. Time itself is changed. I built a time-lapse machine with a camera trigger and a track for linear motion. My system can be used in relaxing nature videos, visualizing traffic flow, or watching your garden grow. To capture a time-lapse is really simple. The process requires basic supplies, a camera and a periodic shutter release, and something to combine the photos as a movie. It's easy enough to set a stopwatch and keep a finger on the shutter button. That's what I did for years, but I wanted to upgrade my system. I would build a reliable and customizable electronic shutter trigger to do the timing work for me. My camera would need to be perfectly motionless in dark scenes, such as moonlit landscapes or star shots. I would be able to keep my hands off the rig, eliminating any chance of ruining the shot. I had another idea right off the bat to make a motorized camera slider. The motor would be controlled from the same unit as the camera's shutter. The project would be a custom time-lapse machine, able to be configured according to the scene, then run on its own for as long as it needs. This control unit was my final project for the electronics program I was in this year. The circuits we were learning about helped me start designing the timer device, the camera trigger, and the motor speed control. First I made spreadsheets to determine the electronic components I was going to use, then I set up different configurations in the lab. I tested many circuits to find the best time values for a smooth time-lapse shot. I needed to design several modules simultaneously because many settings were linked with each other. I started filling a notebook with my designs and specifications. With the goals in mind that my project would fill, my circuit took shape. When the basic interval timer was designed, I moved on to the motor control unit. Many shots would be much more interesting if something new was added: camera motion. Tracks and dollies have been used in film for decades, but more recently, camera motion has been introduced to time-lapse videos. A parallax effect is created when the point of view moves, isolating the foreground and the background objects. The motor speed determines how long a scene is going to run, since the track limits the range of motion. My speed control system would be based on pulse width modulation. While a variable voltage of 3 to 12 volts would work, I wanted to try my hand at designing a 12-volt pulse system. The motor speed is increased by lengthening the 12-volt pulse compared to the 0 voltage time. The generator frequency is high enough that no jitter movement can be seen. I had several ideas for building the motorized track for my camera. I looked online for references of existing products and designs. Professional tracks and sliders were very pricey. Even buying parts individually and building a custom track was more expensive than I could pay for the amateur equipment I was making. I finally decided to build my own system from scratch, using only materials I had on hand. I tried making short tracks from wood or aluminum, but for this video I settled on a 2-foot track made with PVC pipe. I still plan on making a sturdier 5-foot aluminum track with a friend in his shop. My pipe track is flimsy, but once I made several video tests for a demo, I found it's good enough. Next I needed to coordinate the motor and the interval timer. I made some 3D scenes in a program called Blender to help me see what I was going for. I simulated a motor running at 2 RPM along a timing belt, with tensioners on the opposite side to keep it engaged. Another scene depicts a time-lapse showing the theoretical speed of the motor, interval time, track length, and distance reference, which shows the parallax effect I wanted to see. This time-lapse was long enough to show the sun moving from late morning till setting. These scenes helped me select a gear motor for the quickest track speed I would need. I could always slow down the motor, but not speed it up. The 3D visualization also helped to see what time values were best for the scenes I wanted to shoot. I finally had all the pieces together to build my control circuit. I designed the circuit on a computer, then arranged the components and the traces on a virtual board to be cut out by the machine in our lab. Once I started soldering the various components, I realized what a bad design job I had done on the board. I had forced myself to solder under the components already in place, which created solder bridges, broken traces, etc. After the circuit board was finally soldered, I had to do some troubleshooting and solve the bad connections. Once I got the shutter trigger working, I was happy. However, the motor only worked in one direction using the circuit I built. It occurred to me that even this nice-looking board would be a temporary circuit. All that I had made so far was just enough to show what exactly the project did. Right now I run the motor on straight DC power, either with a 12-volt battery or my variable supply. I used the PVC track for the sliding shots in this presentation video, but I will be making better, longer shots with my 5-foot track. I resorted to making a simple shutter timer circuit for the time-lapse in this video. Soon I plan to reconstruct the full-featured circuit with a shutter speed setting for bulb mode on my camera and a motor output with speed control. Once I learn how to better construct the unit, it will be a sleek and very useful system for many occasions. I'm still learning the best techniques of time-lapse photography, improving as I go. This combination of technical design and visual art fascinates me. As I branch off into the challenges to come, I will always remember this project. It made me decide on a subject, then plan, design, test, build, and troubleshoot a complete system. This presentation helped me use my time-lapse knowledge in practical ways. I hope you found it as interesting as I have. Thanks for being a part of my ideas.